Good morning, guys. Today, this is your video on similar figures. Before we get started into the similar figures, I just want to again review a few of the solving of the proportions because, again, a lot of the similar figures will involve proportions and solving them. So, this would have been on the video from Monday. To solve proportions, again, we essentially are just going to cross multiply at all times. So, we're just going to cross multiply here. We'll end up with 3x equals 9 times 3 is 63. I'm sorry, 9 times 7 is 63. And then we would divide both sides by 3, and we get x equals 21. Yeah, hopefully that's relatively easy for you guys. Moving on to the second one. For the second one, again, we're cross multiplying. I tend to always put the x first, so I'm going to just put it first. X squared equals 5 times 45 is 225. Now again, this is important. You will get something like this. So whenever you have x times x, it's x squared. Again, not 2x. X plus x is 2x. X times x is x squared. And then we would take the square root here because it's x squared. And we would end up with x equals plus or minus 15. The square root of 225 is 15. Again, whenever you're dealing with quadratics, you may or may not remember this from Algebra 1, but when you're taking a square root, the option could either be a positive or a negative. So you always want to put that. There are some times where you'll be able to eliminate the negative, and we'll talk about that later, but for now, your answer would be plus or minus 15. For number three, we would again cross multiply here. So you have this and we have this. I'm just going to write it and then I'll distribute. Plus 9 equals 4 times x minus 6. Again, I like to write it because sometimes I find students don't remember to distribute to both elements when they try to do it mentally. But we get 6x plus 27 equals, on this side, we get 4x minus 24. We'll subtract the 2x, subtract the 4x. Be left with 2x plus 27 equals negative 24. We add the 27, we end up with 2x equals negative 51. Divide by 2, and write it over here, x equals negative 25.5. And that'll be that. Alright, so that's just our review for the proportions. So hopefully everyone was able to do those. Again, hopefully you're pausing the video and actually trying some of these problems on your own and not just waiting for me to put up the answers. All right, so for the similar figures, which is our topic for today, let's just get the definition down and then we'll just do some examples on it. Similar figures, these are, moving my picture here, figures with corresponding sides that are proportional. We just spoke about in the previous video what it means to be proportional, so we'll elaborate on that a little bit today. But when figures are similar, the sides are not congruent. They just have to be proportional. So we're looking for them to have that same, that same ratio, like 2/3 to 2/3, etc. They just have to be proportional or have equal ratios for the sides. They do not have to be congruent. When it comes to congruent figures, we're looking for, I could do a better triangle than that. When it comes to congruent figures, we're looking for all of the corresponding sides to be congruent. They have to have the same exact measure. When it comes to similarity, they just have to be proportional. So they have to have that same ratio. The other thing that's going to be true for similar figures, so again, corresponding sides are proportional, and the other part of this definition, and corresponding angles are congruent. So if figures are similar, they have corresponding sides that are proportional, and the corresponding angles are going to be congruent. So I'm just going to do a quick sketch, and then we'll do some examples. So if figures are proportional, we're talking about something like this. Let's say triangle MNO, and over here, let's say this is triangle ABC. So if they are proportional, what this means is that the corresponding sides. Oh, so first of all, let me tell you what the symbol. This is the symbol for similar. Why am I writing symbol? This is the symbol for similar. So if you, well, hopefully you recall, this is congruent. And when it's similar, it's just, this is called a tilde. It's just the tilde part. It's no equal sign underneath. So if they're similar, you're going to see a statement like the following. It'll be triangle MNO is similar to triangle ABC. Now, as soon as you're told that figures are similar, you can automatically conclude that the corresponding sides would be proportional. So if we're looking at this figure here, that doesn't mean we can assume values, but we know that MN, so we can look at the statement, and because MN would correspond with AB, again, you should remember that from the congruency, but it wouldn't be equal to as it would with the congruent figures. They would just be equal to each other. When they are similar, they're going to be proportional. So that's going to mean MN is to AB as, let's go to the next side. The next side would be NO and BC. Again, we would do the corresponding letters, NO and BC. And then the next side would be, all right, remember we do first and last. So it'll be MO, and first and last from here would be AC. So that would be the relationship between the sides. All the corresponding sides have to be equal. They have to be proportional, essentially. Not equal, but they have to be proportional, have that same ratio. And the corresponding, angles will be congruent. So with similar figures, the angles are congruent, the sides are proportional. So we would be able to say that angle M is congruent to angle A, because again, they correspond. We would know that angle N is congruent to angle B. And we would also know that angle O is congruent to angle C. So that is taken directly from the definition. If figures are similar, we know the corresponding sides are proportional, and we know the corresponding angles are congruent. So that's immediately what we would be able to take from the definition. So if we look down below, I have two examples here. We're just going to like practice listing the congruent parts and writing that proportion. Remember that extended proportion we talked about in the previous section, or a ratio, is when you have like multiple things that you're going to set equal to each other, not just two, it's over two. All right, so if we look at this one, we're giving the similarity statement. Triangle ABC is similar to triangle XYZ. So if you look at this, the figure is a little bit different. With the first one, it's traditional. They look exactly the same. They're set up the exact same way. They can be rotated. They can be rotated, translated, etc. So they don't have to be in the same exact, setup, the same exact spot. As we can see here, it is moved a little. So we basically will follow the statement. All right. It says to list all the congruent parts. So again, you want to be careful here when you're listing the congruent parts. It's not going to be the sides. It's just going to be the angles. I'm just going to put example 1 and example 2 here. So for the angles, we would have angle A is congruent to, again, look at this statement, angle X. We would have angle B is congruent to angle Y. And we could also say angle C is congruent to angle Z. All right, so those would be, all the congruent parts. And then we need an extended proportion. So the extended proportion here, again, if we're looking directly at the statement, I wouldn't really worry about trying to get it from the picture. Just look at the statement. And we would say AB is to XY as, again, I'm going to just use different colors so we're clear. Then we have BC and YZ And then lastly, we would have A, C, first and last, and X and Z. So that would be the extended proportion representing all the sides. Everyone try example 2. Pause the video, give that one a try on your own, and then you can unpause it and see what the answers would be for that. Okay, so hopefully that's what you guys got for example 2. We have all the congruent parts. That would be all the corresponding angles. And then, the extended proportion for that one would be, all four sides, corresponding sides over each other. All right, the next definition we're going to look at is what a scale factor is. The scale factor, you guys should be kind of familiar with this term. We've already looked at it when we did the dilations, when we were doing the transformations chapter. So, same thing, but the scale factor is the ratio, because we're dealing with similar figures here. It's the ratio of the corresponding sides of the corresponding side measurements of two similar figures. All right. So when it comes to this scale factor, again, with the with the dilations, we spoke about the scale factor and how it has to be greater than 0. The same things are going to be relevant here. It can't be negative. If it's less than 1, like in between that range there, that's when it's a reduction. And when it's greater than 1, that's when it's getting bigger. It's an enlargement. There's no restriction on how big something can get. So so our scale factor could be like technically infinity. There's no maximum for it. It just can't go below 0. Excuse me. When it comes to this scale factor, I'm going to look at the first 2 examples that we have. There were 2 numbers in the drawings that we didn't acknowledge, so I'm just going to look at those 2, example 1 and example 2, up here as our first 2 to look at and determine the scale factor. So if we looked at example 1, there's a 4 here, and then there's a 7. So here's our 4, here's our 7. So if you're asked for the scale factor for this, sometimes it's also called the ratio of similarity. Just FYI, you will see that term as well. I'll write that down. But essentially it's the same thing. It's just the scale factor. But again, sometimes you'll see that terminology just so you do know. But for this one, for example 1, it's not specifically asking you a direction. So technically for this scale factor, you could have written either, you could have written like 4/7 or 7/4, because there's no direction given. Like if I specifically said, what's the scale factor from triangle ABC to XYZ, then you would say 4/7. But if there's no direction written, you could put either one. So there would be no right or wrong for this right now. And then for the example 2, we have 8 and we have 4. So for that one, our scale factor would be, again, you could put either 8/4, which would be 2/1. And you do want to always reduce, if it's just specifically asking you for the scale factor or the ratio of similarity, you want to make sure those are always reduced. So you could either put 2/1 or 1/2, again, because there's no specifics on which way to go. All right, so there's a few examples below where we're just going to I'm asking you guys, are they similar, and like what's the scale factor? So let's try these next 3, which are involving, again, scale factors, and if they're similar or not, because not all of these are going to be similar. So what you want to do with something like example 1, the first thing, if you look at the angles only. It looks like a yes. But that's not going to be sufficient here because we have numbers. So you want to also look at the numbers. Because if the numbers don't work, then it won't necessarily work. So let's look at number one. The way you would line this up is you would basically, you don't have a similarity statement. So that's the negative to the previous examples. They said, triangle ABC is similar to triangle DEF. We automatically knew what to line up. But when you have no direction, no similarity statement, like we have here, what you want to do is you want to basically just go in size order, because if they were similar, it would have to be the big with the big, the small with the small, the middle with the middle. So I just normally approach it like that. I'm going to start with the smallest two. And if I take the smallest two from each triangle, that's going to mean I have 8 over here and then 10. So it will be 8 to 10. Now, because I put this one first, I would need to stick with that same order. Then I'm going to go middle, middle. So it would be 12 over 15. And then I'm going to go big, big. So for the big two, it would be 16 over 20. And in order to check to see if this is similar, we need to know they're proportional. What you should remember from the last section is they're going to be proportional if the cross products are equal. So if we cross multiplied here, 10 times 12 is 120. And 8 times 15, I believe, is also 120. Yeah, that's also 120. You could also go about it by reducing if you find that to be easier. This would be 4/5, and this would also be 4/5. So that could be another method. And then we could cross multiply here as well. And 12 times 20 is 240. And 15 times 8 is also 240. I'm sorry, 15 times 16 is also 240. So the cross products work. And again, this also reduces to 4 over 5. So if you're good with, some of you aren't good with reducing. If you're good with reducing, you can just reduce it out and show that they're similar, or you could, do the cross products. So the answer would be yes here. Yes, they are similar because, one, the angles work out. We have all the corresponding angles equal. And two, the sides are proportional. So that's the definition of similarity. Corresponding angles are congruent. Corresponding sides are proportional. So check. So then we would write the similarity statement and determine the scale factor. So the similarity statement is going to be triangle. I'm just going to go ABC for alphabetical sake here. And now we can just kind of look at the angles now that we know the sides work. So A had two marks, so D has a 2 mark, so it's going to be D. B has 3, so it'll be E. And then C has the 1 mark, F has the 1 mark, so F. So, sorry, with a congruency statement. Sorry, similarity. So it's just the tilde. So that would be my similarity statement, making sure the order is lined up. And then my scale factor, again, because there's no specific direction, it could either be 4 over 5 or 5 over 4. Both of those would be acceptable. All right, let's look at example 2. So if we look at example 2, the angles work. All the angles are 90 degrees. All the angles are 90 degrees. So that's a yes. Again, you can't automatically say yes, though. You need to check out the sides as well. So I'm going to start with 10 because 10 is the small. And since I have 10 over here, I'm going to go with 15 from here. Again, I'm going to line up the smaller sides. And then the bigger side here is 15. The bigger side here is 20. And again, to see if something's proportional, we cross multiply. We don't need to do all 4 sides because this would have been a rectangle, and in a rectangle, opposite sides are congruent. So we wouldn't need to do the extra, 2 sides because it would be the same. So we cross multiply here. 15 squared is 225. And 20 times 10 is 200. These cross products are not equal. So the answer is no, they're not similar. Again, to be similar, it has to be 2 parts with the angles and the sides being proportional. This doesn't have both, so it's a no. Number 3, this is a quadrilateral. You have 4 sides, 4 angles. All right, so if we look at the angles, looks good. All the corresponding angles are going to work. If the angles don't work, you don't have to bother to try the sides because you know it's a no because the corresponding angles have to be congruent. So we're good. So now let's work on the sides. Again, you need to go small to small, middle to middle, yada yada. All right, so I'm gonna go 6. This is my small from here. And most of us can tell this isn't gonna work, but we're still just gonna go. I'm just gonna follow up with the process. 6 and then 6 would be the small from here. Then I'm gonna go to 12. It's my next side, least to greatest. And then I have another 6 over here. So I kind of know immediately it's not gonna work with that. Keep going. I would have my 24 over here. And then my third side in order from least to greatest would be the 14. And then I have my 24 again. And the biggest side over here is 16. So just from the first cross here, I'm going to get 72 equals 36. It's not going to work. They're not similar. And that would be sufficient, just showing, that the proportion didn't work. If you guys didn't even want to go that far, you could just say sides not proportional. But don't just put no without, a little something. So show, either the proportion doesn't work or the numbers, etc. But put something in that regard. Pause this for a second. Plug my computer in. It just came up to die. Hold on. All right. Got it plugged in. Alrighty, so let me do the last thing. So the last thing we'll be doing with the similar figures is using the similar figures to find missing sides and missing angles, etc. And again, this is where it'll be heavy with the proportions. So here are our first 2 examples. I have four more examples for you guys, and then we'll be all done for today. All right, so this first one, not giving you a statement here. These are pretty much, you'll see some like this where there won't be any letters. It's pretty much just a visual similarity. You can tell, which things correspond. Hopefully it's pretty, again, I wanted to give you a couple like that because not every single one will have the letters. So since these are similar, what's going to correspond, you need to figure out, because there's no statement written out for you, like triangle ABC, etc. Let me see if I did that for any of them here. Yeah, for some of them I do have letters, and then for some I don't. But again, not every single one will have letters. So what's going to happen here, again, this is pretty visual. You can tell which ones line up. I have X, I have Y, I have Z. What you want to do when you're trying to find missing sides is you want to pick the side that you know in both triangles, because you need to have the ratio. So you need to have 2 numbers where the sides are corresponding. So you need like a 2/5, whatever. You do need some relationship between one pair of sides. So I'm going to look for that. The sides that I know in both triangles is I know the 12 and the 20. So that's going to be my ratio, or my ratio similarity, my scale factor, etc. So that's the go-to. Now, once I have that, I could set that equal to. Now, I can, if the question is just asking me for the ratio similarity, I should be reducing that, and my answer should be 4 goes into both. So it would be 3/5. That's the ratio similarity, or the scale factor. But if I'm using it to solve, I don't have to worry about reducing it. I can just keep it in this form and go. So I'm just going to keep it with 12/20. And I'm going to find X first. 12/20 equals 5 from the 12 over X. And then again, I cross multiply to solve proportions. So I end up with 12X equals 100. And 100 divided by 12 is going to give me 8.3 repeating. So that's one of my variables. Now, even though I could use 8.3 to get the next side, I wouldn't want to use that, because just in case I made a mistake, if I use that, now I'm guaranteed to have my next answer be wrong as well. So I'm going to stick with 12 and 20 as the proportion, because I know those are the values for those 2 sides. So now I'm going to say 12 to 20, And now I need y. So I'm going to say y over 18. Now, one thing I just want to emphasize with these proportions, order is very important. You can't say 12 over 20 and then say 18 over y. Because if I'm sticking with, let's say, small, this is obviously the small triangle, and this is the big. If I said small to big, I can't now change it to big to small. When it comes to ratios, proportions, again, order is very important. So you switching it here would definitely make your answer wrong. So you have to be careful with that. So the same as the first one. I had 12 to 20. This is like this is the small, and this is the big. So I had to stick with the small and then the big. I could not switch that. So just keep that in mind when you are solving proportions, that you have to line up the order correctly at all times, or you'll definitely get the incorrect answers. All right, and then you'll cross multiply. So you'll get 20y equals 12 times 18 is 216. Divide by 20, divide by 20, and you get y equals 10.8. And for any of these answers, we're just going to round to the nearest, we're just going to round to the nearest tenth at all times, okay? All right, and then the last part there asks you to find z. So this goes back to way long ago, and hopefully it's in your mind all year, is that this is a triangle. Both of these are triangles. And in triangles, you should remember that the three angles should always equal up to 180. So you already have 33 here. We could put it over here as well, because these are obviously the corresponding angles. We know that this one up here is 98, because again, the corresponding angles being congruent. So that allows us to just subtract from 180 to figure out angle Z. So it's going to be 180 minus the 98 and the 33. So 180 minus 98 minus 33. I get an answer of 49 for C. So that's not a proportion that's going to be subtracting from 180, etc. All right, example 2 is a different type of situation. A lot of students will make mistakes with examples like number 2 without separating the drawing. So let me clarify what a lot of students will do. A lot of students will say 5 is to 24 as x is to 16. And they'll try to cross multiply and solve that problem. And that is always going to be the incorrect way to do this. So let me show you how you should approach this problem and how you get the answers right. So for this problem, what you should see this as is two separate rectangles. So I like to just tell students to take a second to separate it. It doesn't matter like what the size looks like. That's not important. But this is the small one here where this is 16 and this is x. And then the bigger rectangle is this whole thing here. And for this whole rectangle, the bigger one, this side is 24. Everyone's normally really clear with that. But this side is not 5. And it's not 5x, which is a common mistake. This side is 5 plus x because it's these two added up together. So it's going to be 5 plus x. So now we're going to solve this for x. So our proportion is going to be 16 over x, that's my small one, equals 24 over 5 plus x. Now, you could have done it differently, because for a lot of the first examples, I went from one triangle to the other. This one I stayed within the same triangle. Just know that you could have also done 16 is to 24 as x is to 5 plus x. Remember yesterday or Monday when the video with the proportions and ratios, it was clarifying the different ways you can write the ratio. So if you guys wrote the ratio different from me up top, it's not like it's an automatic wrong. You have an option. Remember, you could put the top two together, the bottom two together. Those are some of the different options for like those rules of proportion. So again, I'm only pretty much going to solve them, write it one way, but just know that just because you wrote it differently doesn't mean you are necessarily wrong. You probably will get the same answers because there's like 3 different ways you can write most of these proportions. All right. So anyway, so with that in mind, I'm going to stick with the one that I started with up here. But again, anyone would, there's 3 options that'll get you the same answer. So now I'm going to cross multiply. 24x equals 16 times 5 plus x. 24x equals 80 plus 16x. Let's subtract the 16x. 8x equals 80. X equals 10. So x is 10 for this problem. Now, depending on what was asked, if I just asked you for x, that's it. Obviously, in this case, I didn't ask for anything else, just asked for the variables. That would be it. But sometimes I will ask you for that other, sorry, my ears itching. Take off my headphone. Sometimes I'll ask you for that other side. So just know that this side would have been 15. Sometimes I might ask you for perimeter. So, keep in mind some of the different things you might be asked for in terms of, solving for these similar figures. All right, so here is our next example. All right, so for this example, pause the video, give it a try on your own, and then I'll come back and see what we get. All right, so for example 2, to get started, hopefully first thing you did was connect the angles. I just wrote those in. These are both 37. These are both corresponding. They're 70. And hopefully it's kind of clear that these are being like, reversed to some degree. It's kind of like a reflection. Obviously, it's an enlargement as well, but there's a reflection here. So this is 70, 70, yada, yada. And then we had to find z. So in the quad, hopefully remember that they equal 360. Subtract, you end up getting that z is 163 degrees. Now to solve for x and y, those are the sides. You have to find the one that you have a number for in both. The one I have a number for in both is the 15 and the 20. Again, I'm just going to keep it as 15 and 20. If you wanted to, you could reduce that. It would be 3/4 if you went about reducing it. But that's not necessary. Again, if you're solving it, you don't have to reduce. All right, so since I'm going with the 15 and the 40, I'm going to get y first. All right, so y is going to go on top with the 15. And the thing that corresponds with the y is going to be the 12 over here. So it would be y over 12. Cross multiply, I get 20y equals 15 times 12 is 180. Divide. You should have an answer of 9. All right, one more to figure out what our x is. So I'm going to keep the 15 over 20. And instead of y over 12, I'm going to try to find x over here. So x corresponds with the 6. So it'll be 6 over x. 15x equals 120 divided by 15. Answer is, I think that's 8. Yeah, 8. So those are 2 answers for x and y. And again, you already have z. All right. Here's our 4th and last problem. I don't know why I have a 3 there. All the time. So for 4, our last problem. This one is similar to the rectangle that we looked at earlier, where there's overlapping shapes. So again, what I would do, there's a formula later that'll help you find x a little easy, but it will still give you the wrong answer for y if you try to cheat this process and not think about what the 2 separate shapes are. So again, I'm going to just separate it. This is my small triangle. And in the small triangle, I have 12, 14, and I have y. And then I have the full triangle, which is the big one. And in the big triangle, it's going to be, for the sides, this side is 12 plus x. This side is 14 plus 6, which is 20. And the bottom is 30. All right, so those are the sides. So now that I have everything right, labeled right, now I'm going to do the proportions. So it'll be 12 over, I'm going to go triangle to triangle this time. So 12 over 12 plus x equals, the side that I know in both is this one. This is the side I have numbers for in both. So it's 14 over 20. Cross multiply. 12 times 20 is 240 equals 14 times 12 plus x equals 14 times 12 is 168 plus 14x. Oops. Subtract that 168 and you get 72 equals 14x. Divide by 14. And our answer is x equals decimal 5.1. It's 5.14, etc. But I told you we'd round to the nearest tenth, so we'll stop at 5.1. Excuse me. And then to figure out y, you're going to use, I'm going to go in triangle this time. I just want to show you different ways that you could do the proportions. So I'm going to say 12 to y. Since I stuck in triangle, actually I can't use 12. Sorry, that's not the side to go with. I want to go with the 14 and the y. So if I go with the 12, I would have to use the decimal answer I just got for x in here. And again, you don't want to use something you just figured out, because if that's wrong, then everything's wrong. So I'm going to go with 14 over y, because that's the one I know. And then I'm going to go with 20 over 30. Again, follow the order. So 14y, 20, 30. Can't say 30, 20. Order matters with every ratio. Cross multiply, you get 20y equals 14 times 3 is 42, so that should be 420. Divide by 20. And 420 divided by 20, it's 21. Alright, so those are our two answers for the last problem. Alright, that's it for today, guys. Have a good day.